Clerk.
Section 3, basic automatic controls. Rule 14, automatic control components and applications. Objectives: after studying this unit, you should be able to discuss base temperature control, describe the mercury control bowl, describe system overshoot and temperature swing, describe the difference between low and high voltage controls. Objectives continued. Identify some commonly used low and high voltage controls. Name 2 ways motors are protected from high temperature. Describe the difference between a diaphragm and a bellows control. State the uses of pressure sensitive controls. Objectives continued. Describe a high pressure control. Describe a low pressure control. Discuss the range and differential of the control. Describe the pressure transducers. Describe a pressure relief valve. Describe the functions of mechanical and electromechanical controls.
Recognition of controls component. Recognizing a control and understanding its function and what component is influenced will help eliminate confusion when reading a wire diagram or troubleshooting a system.
Temperature controls, cooling thermostats, close on a rise in temperature, heating the thermostats close on a drop temperature. Used to protect motors from overheating. Low voltage controls are smaller and switch electrical contacts faster and higher voltage controls. Residential systems often have low voltage on controls. Temperature controls continue.
Ooh. Okay, so both of those are thermostats, but they serve different purposes. This is a safety. It is open on temperature rise. And this is a, what is that? Anybody?
A thermometer?
A thermometer. This, it has a thermometer in there.
Yeah,
The space
thermostat, there you go, thermostat.
Okay, so there's two different, they have two different purposes. This is controlling your room temperature, turning it on and off as it needs. This is gonna open if something gets too hot, right? But they're both thermostat.
Low voltage space temperature control. Some facts and components. Carry only small amount of electrical current. Can use mercury or silver coated contracts. Heat, what's that? Anticipator reduces system overshoot. Control a cold anticipator. Intake system lag. Thermostat sub base provides mounting base for thermostat and means to make electrical connection.
Okay, so low voltage space controls. That's gonna be all residential. Is gonna have low voltage thermostats and low voltage controls in the system. Right, that's the purpose of the transformer. Is a transformer? 24 volt control voltage. That means that 24 volts is below 30 volts, which is the National Electrical Code standard for low voltage. So anything under 30 volts is considered class 2 wiring. Class 2 wiring doesn't require conduit, it's not a safety hazard, and it's not a fire hazard. Okay? So our units are gonna run off of 230 volts. Okay? So we have to have a control in there that's not 230 volts, right? So that's why the low voltage comes in. Low voltage controls are faster and respond better. Okay, like that so far? Have we seen one of those before?
Yes.
Yeah? What is it? What is that thing?
Thermostat.
What is that thing in the thermostat?
Mercury.
Mercury.
Oh.
Mercury. Mercury, that's that liquid metal there.
Oh.
You see that?
Yeah.
You don't have that. It comes from planet Mercury.
Oh, for real?
Yeah.
So we go to
Yeah, we
Planet
had to go to
Mercury.
Mercury to get it, but it's toxic, so we don't use it anymore. So
Oh.
we're sending it back to Mercury.
Then why are you trying to go to Mars?
Cause it's a little hot on Mercury.
Because Mars has,
We wanna see what they.
relays that.
We want to see what they have.
They have relays there. Okay, so mercury is toxic, the metal, it was used years ago.
For a lot of things.
But they got rid of it and they're not using it anymore. But you're still gonna find these thermostats out there, right?
Albert Johnny.
They work like that. They're hooked onto that, what is that?
Oh.
Metal right there? Huh?
Bimetal.
Bimetal that's curled up in a coil, and that's called a helix. No? Yeah?
Yeah.
And as that thing expands, this thing tilts back and forth and it makes contact with these contacts right here because mercury is metal. And it's a conductor. Isn't that exciting? Okay, we're gonna talk about this little deal, this little doodad right here. See this little doodad underneath that thermostat? You see that? You see that thing?
Mm-hmm.
That's a heat anticipator. You just read about it, right?
Yes.
That's a heating anticipator. Okay, so on these older thermostats, you're gonna need to know how to set these. Because the customers may not want a new digital thermostat. Right?
Correct.
Okay, okay. So here is on here there is a heat anticipator. This one's a really thin wire. So we'll look at that and we'll check that out. So as far as this heat anticipators, they're only on analog thermostats, like the ones I just handed out. So with our amp meter, we're gonna check the amp draw of the heating circuit while the heating circuit is on. We're gonna see how many amps are going through that circuit. And that's what we're gonna set that indicator with, right? Okay, we got that? We'll go over that again. This right here is a what? What is that thing? Anybody?
A resistor.
Huh?
Resistor.
It's a resistor. It's a resistor. That is the cooling anticipator. Okay, so the cooling anticipator actually allows the system to stay on longer, a little bit longer, to get the system up to working conditions. The air conditioner, when it starts, it just doesn't start cooling. The work also needs to be done is dehumidification. So it has to be on for 10, 15 minutes, right? Okay, so this allows that system to come on and stay on a little bit longer. How it works is it generates just a little bit of heat. Little bit of heat. So inside the thermostat, the thermostat thinks that it's actually warmer than it actually is. So it holds the system on longer. Okay? Understand how that, you're just heating up the thermostat a little bit. So the system will stay on. The cooling anticipator actually holds the system on after it's already reached temperature. So when it reaches temperature, the system won't immediately shut off. Because what's gonna happen is as soon as it shuts off, the air will start to get cold. By the time everything shuts down, the motor stops and everything, because there's a lag with the motor, the blower motor is going to stay on for a little bit. To get that heat out of the heat exchanger, this anticipator just allows that heat to enter the room by turning it off. Actually turns it off early in order to allow for that heat to flow from the unit through the ductwork and into the house. Because otherwise what would happen is it would shut off at temperature. If it shut off at the right temperature, right here, there's all that heat that's getting put into the room after the temperature is already satisfied will raise the temperature. So it actually reduces the system, the temperature lag, the system lag on that. You understand what I'm saying? No? No? So if you turn the heater off and you allow the heater to go through its cycle, once it turns off, the blower continues to run to take the heat out of the ductwork and out of the air conditioner, out of the heater and stuff. Well, all that additional heat gets pumped into the room, causing the temperature to go up past the set point. So this actually allows that to shut off a little bit early and allow that set point to come up when the blower finally stops. Pretty fascinating, really, when you think about it.
Yeah.
Digital thermostats already can consider all of that. Okay, so the main difference between the two anticipators is what?
The resistor.
What's the difference between the two? It's a test question, so I don't expect you to get it.
Wow. Well, what do you expect more from me?
Mechanic. Was it like?
Yeah.
Wrong answer.
What is the difference between?
One's adjustable, one's not.
That's better than I don't know.
Okay.
Line voltage, space, temperature controls. Commonly found on self-contained equipment, like AC or refrigerators. Heavy-duty devices not as sensitive as low voltage controls. Bimetal bellows or liquid-filled remote bulbs. Mercury bulbs / silver-coated contacts are common. Secured cover prevents tampering.
Yeah.
Sensing the temperature of solids, sensing element is insulated for accuracy. Sensing gold should be secured to the solid. Motor protection is accomplished with a thermistor or bimetal strip. Thermistors are often embedded in the motor windings.
Okay, that's the first thermostat we looked at, the one that was a safety, that's what they're for. They're embedded into the motor winding, and they're sensing the temperature of that motor winding. And if the motor windings get too hot, they'll open up. Okay?
Fluids include, liquid and vapors. Temperature measurement is often made by immersion. Bulb can be insulated for accurate measurements. On larger systems and piping arrangements, the thermometers can be mounted in wells.
In wells. So what's a well?
Isn't it a hole and down below has water?
There it is.
What?
There it is.
What?
Okay, so if the water is traveling in this direction, you're gonna put that probe up against the wall of that, so it's gonna sense that temperature, right? And then you're gonna insulate it, you're gonna pack it with something that's gonna insulate that bulb from the outside air. Okay, that's all they're saying. That's it, that's all they're saying. These are more accurate, it's a more accurate means of measuring.
Just simple and stupid.
No biggie, right? Right?
Yeah.
Sensing the temperature of fluids. Fluids include liquids and vapors. Temperature measurement is often made by immersion. Bulb can be insulated for accurate measurements. On larger systems and piping arrangements, thermometers can be mounted in, wait. I'm like,
Where
He read the same slide.
Okay.
This is
Where we at? There?
Sensing temperature in the airstream, usually done by inserting the sensing element into the actual airstream by metal devices such as that flat type, snap disc, or the helix coil. Things to remember about sensing devices. Sensing devices are not mysterious. They react to temperature change. If confused, install the catalog or the supplier of the control.
Okay, so they're not mysterious.
What do you mean by that?
That means you shouldn't be going, oh, what manner of sorcery is this?
Pressure sensing devices measure and or control the pressure of refrigerants, air, gas, water, or other fluids. Used to control electrical switching devices, can be opened or closed on a rising pressure. Used to sense the pressure differential. Used as operational or safety devices. Some controls are adjustable, while others are not.
Ooh. Yeah, okay. Yeah, we'll keep going.
Pressure transducers contain small microprocessors and use pressure transducers. Transducers convert the sensed pressure to an electronic signal. Signal is processed by the microprocessor. The processor adjusts system operation. System changes may involve compressor or condenser and motor cycle.
Ooh. Okay. Let's go back. Sensing temperature and airstream. The best way to sense temperature in an airstream is a sail switch. Okay, this PowerPoint doesn't have a picture of it, but the other one does.
Which one is the other one?
The one that's not in the computer right now.
Okay.
So we're talking about airstream, so sensing airstream. The sail switch is just like a sail, and it's inside the ductwork, and as soon as the air comes on, it moves down and closes the switch, so, that's basically the best way to detect the airflow. Sensing devices are not mysterious, we've covered that. What else? Pressure sensing devices,
We covered that.
all those things are gonna be measured by our temperature sensing. Pressures sensing is using microprocessors. Microprocessors are really big now in commercial units, so they're all over the place. Okay, so if you happen to replace your gauges with digital gauges, you're gonna have transducers in.
Oh, so we're gonna have to change on every once in a while.
What?
We're gonna have to change like the sensors every once in a while.
Not that I know of, but,
Just keep an eye on them.
keep a set of backup gauges, like analog,
Analog.
so you know what you're doing. So you don't trust just your electronic stuff.
I'll be like, but Steve told me this.
I always have those. Those are always gonna give me an accurate reading, right? What are you gonna do when an EMP attack?
Oh my goodness. Oh my
That's right,
goodness.
Steve.
I'm
That's right.
gonna
Continue fixing AC.
Yeah.
I'm gonna continue fixing ACs. One way or another.
You're gonna fix them.
Oh wait, if there's an EMP, it will take out the ACs too.
Yeah, there won't be any switches.
Yeah.
No, cause you'll be able to fix it.
With what electricity?
Just put
Rugged
regular
microprocessor.
analog relays in there.
We're gonna need
Get it
electricity.
going.
Well, even the ones that are not in the machine will still be affected.
No.
No, just your gauges.
Oh, it's
Yeah.
specific.
But you're gonna have backup gauges. See?
You're just giving Steve a hard time now.
Okay, so what does it say? What does it say? What does it say?
Oh,
Oh.
high pressure controls. Normally closed device that open on a rise in pressure. Device is connected to the high pressure side of the system. Used to disable a compressor if the head presses excessive safe limits.
Exceeds.
Exceeds safe limits. Can be an automatic or manual reset device. Can be factory set or field adjusted.
All kinds of different high pressure controls, huh? Most of the time, high pressure control is gonna be a safety.
Safety, makes
Okay.
sense.
And it's, the good ones are gonna be adjustable. You can buy, factory OEM, head pressure, high pressure cutoffs that screw right into the system, so. And, so, but, it'll be up to you, right? Ooh.
Yeah, preference. Anyone?
Low pressure controls, normally closed device that opens on a drop in pressure. Connected to the low pressure side of the system, can be used for temperature control or for low charge protection. Usually an automatic reset device, can be automatic or manual reset devices.
Okay, so low pressure controls are for, can be used for, like I said, if you lose the refrigerant charge, it's gonna open up and it's not gonna, it won't allow the compressor to start. It can also be used as a temperature control to cycle that compressor off and on according to temperature, which relates to pressure. And already known that pressure is relative to temperature with refrigerant, right? Okay.
compressors operate with sufficient oil pressure. Most compressors need at least 30 psi G to operate correctly.
Okay, like a picture of that? Yeah. We have a picture of that.
Whoa.
So the oil pressure, control, it actually got oil pressure, that's right off the oil pump,
Okay.
the hook's there, and then this is the low side pressure of the system.
Like a relief valve.
So it actually, when the system turns on, it actually senses the temperature or the pressure differential to make sure it's there. So the control has built-in time delay, so the cutoff time is normally 90 seconds. So, it can be mechanical or electronic. So the compressor will start up and it'll run for 90 seconds and then check and see if there's pressure there. If there's not pressure there, it'll open up and turn off the compressor. Okay, so 90 seconds gives you time to push that button and leave the premises, and then it's gone, then it's off, then they call you back. So, knowing there's a time delay on that, you gotta sit there and wait for it. So if you start it up, you should have your gauges on it, and watching the pressures and stuff like that. Okay? You guys are get into this stuff. This isn't the time to get into all this technical stuff. We're just learning about controls.
Yeah.
All this will be covered in depth and advance.
Okay.
So,
So that's
I'm
gonna be
just
a
trying to
little,
get you to recognize the controls.
just to know, oh, like that's
That's the
what that
beginning
object
of
does.
troubleshooting. Right there. You gotta recognize what's wrong and recognize the control, right?
Gotta recognize.
So don't get all freaked out,
I'm already
cause
freaking
I'm
out.
going too fast.
I'm freaking out.
You're gonna cover all that stuff.
I feel like I forgot half the
In
things
depth.
you said already.
Talk about that.
Air pressure controls. Can verify airflow through duct systems. Can be used to determine pressure differentials as an interlock between the system blower and electric heaters, and to initiate the defrost cycle on heat pump systems.
Okay, so air pressure controls, also another way to verify there is airflow. Oh, there it is. There's a sail switch. It is in here. So that's what it looks like. Wow.
Wowzers. Not Kelmair?
I know I was gonna say.
What?
Not Kelmair?
No.
Brand. Must be generic.
Oh, Brandon. Dang.
Gas pressure switches detect the presence of gas pressure in gas burning equipment before burners are allowed to ignite. A safety control that should never be bypassed.
Okay, so gas pressure, switches, especially some of the old ones will have an actual pressure switch in the gas line, and it's not gonna allow that unit to do anything if there's no gas pressure. Okay, it's just a small little gas pressure sensing device that, will let you know there's gas in there, so it won't light the pilot and it won't start the burners. But they've gone more sophisticated than that, they have other ways of testing and see if the gas valve is actually, on or running, so. But we've got a whole mod that we're gonna learn heating. So, don't freak about that. But it's funny that it says safety control that should never be bypassed. I looked up this word in the
Never?
Greek and the Hebrew,
Uh-huh.
and it means never.
What?
Shocker.
But only
Shocker.
that safety control, all the other ones are okay,
Yeah.
Yeah. You can bypass every other one, but except that one.
especially GFI.
That's a great word.
Uh-huh. Okay.
Check it out.
Greek and Hebrew.
They were out there saying never.
Never.
Means the same thing.
Cool.
Are you gonna pull a Taylor Swift on this? Never say never.
That's just.
Devices that control fluid flow and do not contain switches. The pressure relief valve, considered a pressure sensitive device, detects excess pressure in any system that contains fluid, water, or refrigerant.
Okay, we all have one of those, right? This is not electrical. This is just strictly mechanical,
Yes, correct.
but it still is a control, right?
Correct.
Okay? So, it should never be bypassed either. I don't know how you're gonna bypass it. You bypass it by not putting one in, then you have a problem.
Water pressure regulators. Controls water pressure to main system components. Often use a hydronic heating systems and systems using water-cooled condensers. On hydronic systems, a valve opens on a drop in pressure to add water to the water circuit. On water-cooled systems, the valve opens on a rise in head pressure to increase water flow through the condenser.
Okay. You guys understand that?
Kind of.
It's just a water valve that modulates the water flow. Especially through water-cooled condensers, that's what they're gonna use. The water-cooled condenser, as the pressure goes up in the system, it senses the pressure and opens the valve for more water to flow through. The water-cooled condenser. Okay.
Gas pressure regulators. Gas switches are often used as safety switches. Gas switches are normally closed devices and will remain closed unless an unsafe condition exists. Should never be jumped out. Gas regulators reduce gas supply pressure to the working burner pressure and be adjusted.
Okay, so there's that word again. Never,
The Greeks were saying that.
never. Huh? What?
That's what the Greeks said.
Yeah. So, we're talking about gas heating and stuff like that, and it says you should never jump these out. Don't ever do it. You can jump them out to test them, but that's it. So if, by chance, if you're in heating and working in heating, and the system is acting funny, and you can't quite figure it out, and it's not acting right, the burners aren't coming on the way they should, if you feel that system is unsafe, your job is to turn it off, cap it, and red tag it. Okay. If you're not sure, red tag it, cap the line, and walk away from it. Because if it's gas heating and you let it go and it ends up
Blowing up.
exploding or killing somebody,
It's your fault.
you're liable for it. So if you're not sure, due to you can't figure out what it is, or you're inexperienced or whatever, turn it off. Your boss will send somebody else out there to check it out. But I'm sure your boss is gonna appreciate the fact that you shut it off because you didn't feel it was safe. Okay, rather than, I don't know what I'm doing, I'm just gonna leave it running. Okay, so that's one thing we can't Mickey Mouse is the heating. Don't Mickey Mouse that stuff. Air conditioning, we can kinda Mickey Mouse a little bit, but it's not gonna do anything. So, heating, we can't Mickey Mouse. You know Mickey Mouse, don't you?
Yeah. There's a lot of that out there.
Okay, so what is that? Anybody know what that is?
I don't. I seen it. I know.
You seen it?
I seen it outside buildings. Yes.
What?
That's a
Gas pressure regulator.
Wow.
Pressure regulator. Wow.
Learn something new every day, Nate.
Uh-huh. You got them right here on the gas meter, right here? Check it out.
Correct.
Check it out, right there. Ooh. Ooh.
Mechanical and electromechanical controls. Mechanical controls operate independently from other controls, for example, a water regulating valve. Electromechanical controls convert mechanical movement into some electrical activity, for example, a sail switch.
Maintenance of mechanical controls. Water regulating valves should be checked for leaks. Corrosion, wet spots, and rust indicate leaks. Pressure relief valves can be tested by lifting the lever. Check to make sure that the valve seats properly. Be careful since the water can be very hot.
Okay. Those last three statements right there are referring to the pressure temperature relief on your water heater. Okay, so you can lift the lever, but make sure that it seats. Okay, you can go home and try that now.
No,
Why not?
I don't want to mess up. I don't know.
Maintenance of
I feel like there's more to it, the story, that's why. Sorry.
Okay. Maintenance of electromechanical controls, check for water leaks if applicable. Check transmission lines for leaks, ensure that controls are mounted securely. Check for frayed or burned wires, and check for excessive control vibration.
Okay, so those are all things you're gonna look for when you're doing maintenance and repairs too. You can start the thing up, you can check all that stuff. Okay, that good one? Sure.
Summary, space temperature is controlled by thermostats. Thermostats can also be used to protect electrical components. Heating thermostat goes on a drop in temperature. Cooling thermostats can close on a rise in temperature. Summary, pressure control opens and closes in response to sensed pressure. Mechanical control operate independently of their controls. Electromechanic controls result in some electrical activity.
Okay, got that?